In this video, we will have a look at Microsoft Azure Network Security Groups. So network security groups contain rules that allow or deny traffic to virtual machines within a virtual network. And you can associate a network security group to a subnet or to the VM network interface card itself, restricting traffic to and from that individual virtual machine. NSGs or network security groups contain inbound and outbound rules, and for each rule you can specify the source and destination addresses, the port or the protocol, and an action of allow or deny. And a comment, you can add a comment in there as well. So we will take a look at the security rules themselves very shortly. Looking at the diagram in front, this is the diagram we will work with, and with the network security groups you can apply them or associate them at the subnet level, this level here. So you can apply them at the subnet level, which will affect all the virtual machines within the subnet, or you can apply them to the network interface cards of the virtual machines. So you can apply them to either this network interface card here or this network interface card here, so the interface cards themselves. When you associate an NSG to a NIC, a network interface card, the network access rules in the NSG are applied only to that specific NIC. So for example, if a virtual machine, let's say web server 1 here, has two network interface cards, it will only apply to the network interface card you apply it to. The other one will not be impacted. And when an NSG is associated with a subnet, the rules apply to all the VM instances in that subnet, which we will take a look at shortly. So you can apply them at both levels, but best practice would be to apply them only at one level. So don't apply them at the subnet level and at the network interface card level, as it gets messy and difficult to manage and troubleshoot that way. Unless of course you needed different rules for each virtual machine. If you needed different rules for each of the virtual machines, then you may want to create network security groups for each individual network interface card, and you may still have a subnet level NSG that has common rules to all virtual machines, such as allowing them all access to the internet or something. So there can be use cases where you would want to use both levels at the same time, the subnet level and the network interface card level, but try and keep it as simple as possible if that's possible. So even if you apply an NSG at the subnet level, it will still impact virtual machines within the subnet. So for example, you can block communication between VM server 1 and VM server 2 within the subnet, even though it's applied at the subnet level. So it's not just in and out of the subnet, it's communication within the subnet as well. And when you create a network security group, you can associate it to as many subnets and to as many network interface cards as you need. So this is what my diagram looks like. We've got an Azure subscription. We've got a VNet here. It's called web server-VNet. You can see it on the screen over here as well. And we've got a subnet. It's called web server-subnet. This is the subnet. We've got two virtual machines in the subnet. The subnet network address is 10.110/27, and we can see the subnet IP here and the range here. So Azure reserves 5 IP addresses from the subnet. The IP addresses are 10.114 assigned to web server 1 and 10.115 assigned to web server 2. And now if I bring the SSH sessions into the picture, we can ping each of the clients from each other, and they are fully pingable. So web server 1 and web server 2, I can ping each web server. I can do the same from web server 2, ping 10.1.1.4, and they can ping each other fine. So here is my VNet. It's called web server-VNet, and if we go into the VNet, I've already created the VNet of course. We can have a look at the subnets within the VNet. Actually looking at the address space for the VNet is 10.110/20, and then the subnet is a subnet of this address space here. So it's a smaller subnetwork of this address space. So this is the full address space. And so if we go to the subnets, actually over here we can see the devices as well, the network interface cards of my virtual machines, and we can see the IP addresses here as well. Now if we go to subnets here, we can see the subnet I've created, web server-subnet. We can click into that as well, and we can see the subnet properties over here. Currently we have no network security group associated with this subnet, but we will do this very shortly. And if we go back to the home page and we go to virtual machines, we can see our two virtual machines here, web server 1 and web server 2. We can see the public IP addresses here, so I can SSH to them. And if we go into web server 1 here, I can see the public IP address here and the private IP address associated here. If we go to networking here, and we can see the inbound port rules and the outbound port rules over here. So the top port rule here, the top rule, the inbound rule, this is the one that I've created as part of creating the virtual machine itself. So I asked for this to be open so I can connect to my virtual machine over SSH. And the three rules below it are default rules. These cannot be deleted, but they can be overridden by other rules you create yourself and you customize yourself. So if we go to outbound port rules, we will see the three default rules here as well. And going back to inbound port rules, the default rules cannot be deleted. However, as they are assigned the lowest priority, they can be overridden by custom rules. So the priority is 65,000, 65,001 and 65,500. And with the priority, the rules are checked in order of priority. So the range that we can create them is between 100 to 4096. And Microsoft recommends jumping priorities by 100 for each rule. So rule number 1, priority 100. The next rule will be priority 200 and so on. And the reason for this is to leave space in the numbering for new additional rules. You want to put in a specific place for the rule base. For example, to put a rule in between rule 1 and 2, you can use any number between 100 and 200 if you have rule number 1 as 100 and rule number 2 as 200. Unfortunately, you're not able to move the rules up and down with other real firewalls. This is the only way you can do it. So you have to rely on these numbers for positioning them in the rule base. So the first rule says allow SSH on port 22 on TCP from the source anywhere to the destination anywhere and to allow the traffic. And I put this in place to allow me to get onto the virtual machines via SSH. And I call the rule SSH. The second rule, 65,000, permits any other virtual network to communicate with this virtual network on any port or protocol. And 65,001 here allows load balancer traffic into this network interface card. So we can see the source is load balancer and the destination is any. And just to remind you again, we're looking at inbound port rules, so these are inbound. And 65,500 is to deny everything else with a deny action at the end. And we can see here everything else is denied. So port, protocol, source and destination is any, and the action is deny. And we can see these are inbound port rules in perspective of the web server NSG here attached to network interface card, and this is the network interface card of this virtual machine. So going to outbound port rules, we can see the three default outbound port rules. So the first one, 65,000, is saying allow connectivity on any port and any protocol from this virtual network to any other virtual network, and the action is allow. And 65,001 is saying allow any connectivity from anywhere to the internet, so allow connectivity from this network interface card, which is here attached to network interface card, and that's the network interface card of this virtual machine to the internet. So this virtual machine can talk to the internet on any port or protocol. And finally, 65,500 is saying deny anything else with an action of deny. By the way, these descriptions in the source and destination addresses are called tags. Default tags are system provided identifiers to address a category of IP addresses, and they're used in the source and destination address fields. We can see the tags are being used in the default rules, in particular a tag for virtual network, a tag for Azure load balancer, and a tag for the internet. The virtual network tag is basically the VNet address space, and the Azure load balancer tag is the Azure data center IP where Azure's health probes originate. And finally, the internet tag denotes the IP address space that is outside of the virtual network and reachable by the public internet. To create a brand new network security group, we can go to the Microsoft Azure homepage and we can click on network security group from here. We can see the current security groups here. I can create another one. I created this one previously, but I can create another one from here, create, and we can give it a name. of web server 2-nsg, and we can associate with a resource group. Let's associate with the web server -rg resource group. We specify the region, and then we just review and create this network security group. And I'm missing some information, so go back to basics, and we can see over here there is already a resource with the same name and type with the current resource group. So let's change this to -subnet instead, and we will associate this network security group to a subnet. Let's call it 2, and review and create. So there we go, we've created our brand new network security group. If I need to click on create here, and it will create the network security group. The deployment is in progress. Once this is deployed, we will be able to see the network security group, and it's been deployed. Deployment succeeded. So if I go to resource here, we can see the network security group here, and we can see our inbound security rules and our outbound security rules all in one page over here. And I can apply this network security group to my web server subnet, but before I apply it, if I go to inbound security rules here and I create a rule to allow SSH inbound, and the reason I'm doing this is to allow my SSH sessions to my virtual machines. So I'll leave everything as any. Star denotes any, destination will be any, service will be custom. Let's go with star here, and let's go with the protocol of ICMP, an action of allow. Let's go with 110 for the priority, and let's go with the name of allow_SSH. Let's add that to my inbound rules, and now we can see that over here at the top. So that's good. So what we can do now is, if I go to Microsoft Azure from here, the home page, and go to virtual networks, and if I click on my virtual network here, I can go into my subnets from here, and I can see my web server -subnet here. If I go into my subnet now, I can associate that network security group with my subnet. So I can click on the network security group we just created, which is web server -subnet 2 here, NSG, and click save here. Now I've got 2 network security groups associated with my virtual machines. If we go back to the diagram, we have a network security group associated with the subnet as a whole itself, and when you associate a network security group with the subnet, it applies them to the virtual machines. And then we have network security groups applied to the network interface cards as well of the virtual machine. So we've got 2 layers set up currently, and the one trick about the 2 layers is, if you have both layers set up, and let's say for example you wanted to allow port HTTP from the outside world to your public facing web servers, you have to allow it on both layers, and that's why I put in the SSH access. So for example, if HTTP is allowed on this network interface card inbound to the web server, it needs to be allowed on the subnet level as well. If one of them is blocked, it will block access. If it's blocked at the subnet level, it will block access. So you need to bear that in mind. Even if it's allowed on the NIC level and the rule has not been created on the subnet level, it will not allow you access. And that's the reason I put in the SSH on the subnet level as well. But to understand which network security groups have been applied to these web servers, what we can do is go to the home page and go to the virtual machines from here. And if we click on one of the virtual machines, let's click on web server 1, then go to networking here, and we can click on something called effective security rules here. If we click on that, this will show us the network security groups associated to this virtual machine. We can see the scope here. The scope is this network interface card, which is web server 1263. That's the name of the network interface card associated to this virtual machine. And then associated NSGs, we can now see I've got my network interface card NSG here, web server 1-NSG. And I've also got this one here at the subnet level, web server -subnet 2-NSG as well. And you can see them down here as well. If I go back to web server 1 here, we can also see a topology as well. It will show us a topology from a networking perspective. So I can see the virtual machines here, web server 1 and web server 2. I can see that they are part of the web server-virtual network, and they are part of the web server subnet. And then I can see that we have network security group associated with the virtual machine, and I can see the network interface cards associated with them, and then I can see that they both have a public IP address as well. So if I bring my diagram back up, we can do some access rule tests, and we can test SSH out. So at the minute we've got SSH access on the subnet level, and we've got SSH access on the NIC level as well. To verify that, if we go to the virtual machine here, and we go into the virtual machine, the web server 1 or web server 2, but let's stick with web server 1, go to networking. And over here we can see both network security groups applied to this virtual machine. So we can see the top one, this is the network security group, which is here, network security group web server -subnet 2-NSG, that's the network security group name, which is attached to subnet web server -subnet. So this is a subnet level, and we can see the rules here. And the top rule is to allow SSH inbound. So it's at the inbound direction. We can see here, these are the inbound port rules. And the second network security group is the web server 1-NSG, and that's attached at the network interface card level. So we can see a network interface card here, and that's the card name of the card attached to this virtual machine. And then we can see the NSG rule set down here, and we can see at the top it's got the SSH access on the inbound level as well. So it's allowing SSH access inbound. And we can see the port and the protocol here, the source and destination is any, and the action is allow. So this is where you would come if you want to verify the rule base on your virtual machines and see what's being implemented. But to check the subnet level NSG and to see where this has been applied, if we go to Microsoft Azure homepage, we go to virtual networks, we go to web server-VNet, and we go to subnets here. We can see the web server-subnet here. We can see the associated network security group here. If we go to the network security group and we have a look at that particular network security group, and we can see the rules here, and we can see allow SSH here as well. So at both levels SSH has been configured, but if we change this rule to block, let's have a look at the SSH sessions first, just to make sure that they are still running. So they are still running perfectly fine. Let's change that to do a ping to 8.8.8.8, and it can ping the internet fine as well. Now let's deny access, and let's click save and see what happens. So I think the current sessions will have no problems and will run absolutely fine. But if I open up a new SSH PuTTY session, let me go back into the virtual machine to figure out what the IP address is. Let's go to web server 1, and the public IP address is here. So if I open up a PuTTY session and type in the IP address 20.117.148.100, and it's opened it up on my other screen. If I move that here, we can see that the session has been denied. So the session has been denied because at this subnet level I have denied access to SSH. So what we can do is deassociate the NSG from the subnet level here. Remove the NSG from the subnet altogether, and that should give me SSH access again. So let's do that. Let's go to Microsoft Azure homepage. Let's go to virtual networks, and then let's go to web server-VNet from here, and let's go to subnets. Now let's go into the web server-subnet, and then in the network security group here, let's click on none, and then let's save that and see what happens. So that's been saved. Let's go back to my virtual machine again so I can see the public IP address over here, and let's open up a PuTTY session again, and let's type in that same IP address, 10.117.148.100, and that should give me a putty session back to this virtual machine. And we can see here that it's given me access to this virtual machine again. So just by removing that NSG from the subnet level, it's giving me access again, because I have a SSH rule on the network interface card level allowing me access via SSH. Right, for test number 2, what we can do is, if we have a look at my diagram here, we will apply that NSG again to the subnet level here, but what we will do on the subnet level, we will deny access from 10.114 to 10.115 and see if that blocks access. So if we go to the home page again and go to virtual networks, actually if we go to network security groups and go to this network security group here, and if we put that rule back in, or we change it to allow from here, and then we click save, now SSH has been allowed again. We need to associate this NSG to our subnet, so if we go to home page, virtual networks, and then we click on the virtual network web server here, and then go to subnets, and let's associate this NSG to this subnet. So go to network security groups and then choose our network security group here and click save. So the network security group has been associated, but actually I have to go back into it to add the new additional rule. So let's go into web server -subnet 2, go to outbound rules, outbound security rules, and then let's click add here. So the source address will be IP address of 10.1.1.4 and destination will be 10.1.1.5. Let's just put a star for the port range, and let's click ICMP for protocol, and let's click on deny. Let's call this deny underscore ICMP. Sorry, that's the priority. Let's go with 115 for the priority, and let's give it a name of deny underscore ICMP. And before I click add, let's go back to the web server sessions, and let me make sure I can ping from 10.114 to 10.115. So if I do a ping 10.1.1.5, and I can see I can ping it fine. So let's click add here. We are now denying ICMP protocol from source 10.114 to destination 10.115, and the action is deny. Let's have a look at that and see how long it takes to kick in. We can see after 10 seconds the ICMP has stopped working. So ping has stopped working from 10.114 to 10.115. I should still be able to ping 10.115 from here. Ping 10.1.1.4 should I say. And I can ping the other way around because I've not blocked it the other way around. I've only blocked it from this side, which is ping 10.1.1.5. And ping has been blocked. So what we've done is at the subnet level I've applied the NSG, and at the subnet level I've blocked ping from web server 1 to web server 2. So even though I've not blocked it from the network interface card level, I've not blocked ping from web server 1 to web server 2, but because the rules at the subnet level are applied to each and every virtual machine within the subnet, it takes effect. So as you can see, NSGs can be a bit tricky to work with. Just make sure if you are using NSGs at both levels, the rule is applied at both level and not just one, otherwise it will not work. And even better, with NSGs, try not to use them at both levels. Just use them at one level or the other. Use them either at the subnet level or the network interface card level.